Hello, everyone. Thank you for joining us today. I'm Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. Today, folks, as we get our event started, we do have Andy Grover with us today, and he's going to talk to you all about the Linux Way, rebuilding the Unix era for a new era. We would like to thank our sponsor today, Media Temple, and to let you all know that from its inception in 1998, Media Temple has been on a mission to help people and businesses succeed online. Over 125,000 customers in 100 countries now rely on Media Temple's simple tools for domain registration, web hosting, business applications, virtual servers, and other cloud servers to power more than 1.5 million websites. Media Temple takes pride in offering a premium service at a competitive price, along with exemplary 24/7 customer support. Media Temple's customers range from everyday people to top bloggers, creative professionals, and small businesses, as well as large enterprises like Starbucks, Adidas, Samsung, and Toyota. With 200 dedicated U.S.-based employees, Media Temple has been repeatedly recognized as one of the fastest-growing companies in North America and one of the best places to work. You can find out more about Media Temple anytime on the web at MediaTemple.com or on Twitter at MediaTemple.com. Again, a big thank you to Media Temple for sponsoring our event today. Okay, folks, we'd like to let you all know a little bit about our speaker today and changes to the kernel itself, as well as low-level management tools. Previous work areas include networking and ACPI. He lives in Portland, and folks, we're really excited to have Andy with us today to present this webcast for you all. A little housekeeping now, just to kick off our event to ensure you get the most out of the webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Andy. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Andy, please preface them with a capital letter Q so we know that they're for him and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget today, you might need to give it permission to access your account. Our hashtag today is OzCon, all one word. And the Twitter widget will automatically append it to your tweets so you don't have to. Folks, we'd like to let you know we are recording the webcast today, and we will have the archive ready usually within 48 hours. And now it's my pleasure to turn the program over to Andy for his presentation. Good morning, Andy.
Good morning. Am I coming through?
Loud and clear.
Great. Well, hi. I'm Andy Grover, and I'll be talking to you today about the Linux Way and how it's grown out from the Unix Way. Thanks to O'Reilly and Yasmina in particular for the chance to speak with you today, and thanks to you all for attending. This is the first time that I've given this talk. I'll be giving it again at OzCon, so I welcome any feedback for improvements that you have. By the way, while I am a Red Hatter, I'm not speaking to you today in a work capacity, so please send your feedback to my personal email, which was listed on the title slide. Okay, so I'm assuming you all have tried Linux at some point. Today, I'm going to be talking about the classic use of Linux with GNU and other software, the Linux desktop, with a command line and all that. I'll try to explain things, but this talk does assume a basic level of familiarity with Unix-style tools. Next, let me also mention that this is a philosophical, hand-wavy talk. It's not about a specific technology too much, but discussing the way that we want our free and open computing platform to evolve. The nature of open source means that all of us here, in our capacity as users and developers, are the ones ultimately responsible for deciding what we want in our OS and guiding how it gets there. So let's get started. What is the Unix way? Well, first of all, the Linux platform is a Unix clone. It started out with the specific goal to conform to the specifications that define the Unix platform, called POSIX. Before we get into what it does differently, let's look at some tenets, the core guiding values that embody the spirit of Unix. First of all, keep it simple. Now, this might come as a surprise to someone new to Unix who's confronted with all the bizarrely named commands, but Unix is supposed to be simple. Once a user is familiar with it, the Unix command line provides a toolbox of simple programs that can be combined in useful ways. This approach, simple tools and straightforward abstractions, also extends to writing code for Unix. Unix's core programming model is that everything is a file or can be treated as a file. This means that once you know how to open, read, and write a file, you also know how to access other things that behave like files. This is very powerful.
Hi, Andy. Sorry to interrupt for a moment. Thanks
Sure.
for not seeing your slides advancing. Are you able to click next?
Oh, I'm sorry. Yes, thank you for reminding me.
Sure. Back to you, Andy.
Okay. Not too much on the slides, so hopefully we'll be good from now on. So keep it simple. The drive for simplicity even extends to how the operating system is implemented, its internals. Simplicity in Unix is a virtue in both how easy it is to use and the elegance of its inner workings. Next, write programs that do one thing and do it well. Write programs that work together. So in classical Unix, ls just lists files in a directory. If you want to sort the list of files, you would use pipes to hook up the text stream output from ls to the input of the sort program. Sort would read its input from what ls passed it, and then change the data by sorting it, and then write its output, which could then be further chained if desired. So in this example, both sort and ls do just one thing. ls prints the file names, and sort sorts the text stream that it's given. Each of them does one thing well and works together to achieve the combined result that you want. That said, piping ls into sort these days isn't done very often. For common sorting choices, ls now can sort its own output, and using ls's built-in sort options are usually less typing than piping to sort. But the principle remains that linking programs via pipes as filters for a text stream is a powerful ability and an example of the Unix tenets. This isn't a universal among all programs, however. Programs must be written to handle input in this style, and graphical apps or programs that don't originate on Unix won't always enable this. Choose portability over efficiency. Store data in flat text files. So Unix was successful partly because it was written in C instead of assembly language. This let it run on new hardware much more easily, helping Unix spread. And usually new hardware was faster hardware. Therefore, in the long run, portable code can run faster than if it is optimized for efficiency on one type of machine. Of course, if your code is portable and efficient, so much better. Now, regarding text files, using flat text files when possible keeps things simple and ensures the contents will be able to read by many different programs now and in the future. So it all comes back to keep things simple. Next, use software leverage to your advantage. Use shell scripts to increase leverage and portability. This is yet another way of keeping it simple. You don't write some code if you can get the functionality for free by harnessing existing code that has already been written and debugged. Shell scripts are a fundamental part of the Unix platform. They enable users to get more done more quickly. They also inherently don't use platform-specific features. They're portable. The user knows what they're doing, right? Don't we always? Well, how about RM? There is no undelete in Unix, except restore from backup. The other thing is that commands usually don't say job done or extraneous text. They just output the minimum, sometimes nothing, unless there's an error. Separate policy from mechanism, separate interface from engines. Now, these ones are a little deeper and less about Unix command line tools and more about how the responsibility for running the machine should be divided between the kernel, the privileged code that can access the hardware, and user space, all the services and programs run by the administrator and all the users. These describe the best breakdown for what should be in the kernel versus in user space. Basically, the kernel should have the minimum. So let's say a Unix machine is controlling a robot arm. There are two parts to this control. First, something needs to know how to tell the robot arm to move its various parts. And then, something also needs to have a list of the movements that it should do, maybe over and over to pick up apples. The first part, the how to make the arm move, is what we call the mechanism. The how to do something. It probably needs to be in the kernel because it needs to access hardware. Then the second part, the what moves should the arm make, is what we call the policy, the what to do. Typically, once you write the how, you never need to change it much. You've enabled control of the arm, and how it's controlled won't change until you get a new robot arm. But the policy can change a lot. Instead of picking up apples, you want it to pick up cherries. So you need to grip something smaller. You can change the amount the robot grips by changing just the policy code. The policy, the what, tends to change more rapidly than the mechanism, the how. So by separating them, you don't have to mess with the mechanism code. You just change the policy code as needed and keep as much code out of the kernel as possible. Whew. Okay, so that's that. Well, how about the second one? Separate interface from engines. Well, this is talking about another case where separating and modularizing code can be a good thing. An engine in this context is a piece of code that does something significant that you really only would like to write once, maybe decoding MP3s and playing them. An interface is how we interact with that engine, such as a graphical interface or a command line interface or a web interface. If we write an MP3 playing engine with a graphical interface and don't separate the code, it may be very difficult to come along later and add another interface to the same engine, or use the engine without the unused GUI code tagging along. In fact, it might even be easier to write a whole new MP3 decoder than untangle the GUI from the engine. Well, maybe you're thinking, well, of course, why would anybody ever do that? But it happens. So hopefully not that much. Next, let's see how Unix evolved. So here's a simple picture from Wikipedia covering the evolution of Unix since its inception. First, there were the early years. The inventors of Unix worked at AT&T, but AT&T couldn't sell Unix due to a legal agreement, so it was given away to universities and others. By all accounts, this was a great time to be a Unix hacker. This period of furious innovation led to Unix version 7, considered by some to be the best Unix ever, released in 1979. Then came the Unix wars. Non-commercial development of Unix continued around BSD, the Berkeley software distribution, but starting in 1982, AT&T started licensing commercial versions of Unix, which was adopted by a number of vendors like Sun, HP, and SGI. This era almost killed Unix, according to some. There was severe fragmentation of features among all these vendor Unixes, although many technologies that we use today on Linux were developed on commercial Unix, including inter-process communication, sockets from BSD, NFS, X-Windows, shared libraries, virtual memory, and System 5 init. These are things that we could not live without today. So it wasn't all bad, right? Finally, there's the free Unix renaissance. In the early 90s, Microsoft was getting serious about Windows NT, and various Unix vendors started to cooperate a little more to unify Unix. But in the meantime, Linus Torvalds was working with like-minded individuals over the newly accessible Internet to develop Linux. Used along with the code from Richard Stallman's GNU project, it was possible for ordinary people to both build a Unix-like system as well as to actively hack on it, which was a lot of fun. Okay, so now let's talk about Linux. We have the early years, then the Unix wars, both of which defined the characteristics of Unix as we know them. But today, Linux is moving forward, mostly on its own. So I'd like to introduce the term flows, which I'm pronouncing flows rhyming with nose because there's another term, floss, which means something different. So for the purpose of this presentation, we'll be pronouncing it flows. This is what it stands for: the Free Desktop / Fedora Linux Operating System. In an insightful blog post last year, a blogger named Paul Eberhard coined the term flows. Flows is the name for what Linux has become today. It's not necessarily good or bad, but Linux is definitely different from Unix. And this gives a name about it so we can talk about it and compare it. There have been a lot of changes to the Linux platform in the last decade, and not everyone has been happy with all of them. The changes don't necessarily go in the same direction as Unix, but do they actually go in the opposite direction? Let's look at the flows principles and see how much they apply. The first flows observation is avoid scripts in favor of descriptive configuration files. For those of you on Fedora or Ubuntu, you know that these two distributions now have new ways to start services and control services. Fedora has systemd, and Ubuntu uses upstart. Both of these try to speed up the boot process and handle dependencies between services better than System 5 init. Although many other daemons have configuration files, this is a clear example where the old way of doing something was script-based, System 5 init, and the new way purposefully removed scripts. With systemd, for example, each service, each daemon like an SSH server or web server, still has a text file that describes how it should be handled, called a service file. But if you looked at the System 5 scripts on an older system, such as etc initd sshd, it was a script that took start or stop as a parameter, and you could just run it on the command line, and it would do it. Now, these were usually pretty long, maybe a couple hundred lines that were mostly the same for each startup script in etc init.d, and that's how it worked. With the new systems, the SSH daemon's service file isn't a script that you can actually run. It's a flat text file with configuration settings that systemd reads, and then you ask systemd to start the SSH server, and it does. The next observation of flows is the emphasis of machine manipulability over human manipulability. To put it another way, this means, is it easier to configure Linux if you're a person or if you're a program? Way back when, if you were an admin for a Unix machine, you tended it. You lovingly edited the configuration files to be perfect, and you could gracefully configure a new service to coexist nicely with the other ones using your trusty text editor. Things didn't need to work out of the box because the admin there was there to fix things up by hand. But these days, an admin is responsible for many more machines. Virtualization and the cloud mean an admin may be responsible for hundreds of machines, but now maybe they're virtual machines. That doesn't make them any easier to manage necessarily. To cope, configuration management tools like Puppet, Chef, and Ansible help the admin to automate more of setting up services and configuration on a machine. Now looking at this in an objective way, this is definitely happening. More things have library interfaces or APIs, along with command line programs, than before. Some command line tools have special fixed format output modes meant to be parsed by programs even. The one question I have about this observation is are we prioritizing automated setup over human setup or just in addition to human setup? It's still possible to not use these tools. I certainly don't on my laptop. When is this a problem? Or when does this become a problem? Next, Flows notices the use of DBus rather than the traditional Unix sockets and pipes. DBus is a system local shared message bus. The host of kits like Console Kit, Policy Kit, and Package Kit on a recent Fedora system all make use of DBus. DBus is implemented using traditional sockets, but the API it provides is a richer, more complex one. You can subscribe to messages and send to multiple recipients, that kind of thing. No doubt it's something version 7 Unix didn't have anything like. But is that good or bad? Can't we build higher level abstractions on top of the Unix fundamentals? What would the creators of Unix say, I wonder? Monolithic programs which attempt to synergistically manage multiple complex components, which is a very word of saying there are now big programs that do lots of stuff in more everyday terms. And there are. Systemd, of course, is an example of this. In addition to init, it also has scooped up a number of functions that used to be handled by separate daemons, with the argument being, well, why not just save one whole running process by adding a little more code to systemd? It definitely could be justifiable, but now the question around systemd is, when does it stop? It seems to just keep eating other little daemons. Also, traditional Unix has tended to have many single-purpose daemons, but then it also contained the inetd superserver daemon, which would listen on multiple ports and only start the actual daemon when there was a connection. So what about inetd? Is inetd Unixy? Does it follow the Unix way? What's the line? Does something become part of the Unix way simply because it's been there a long time? So it's an interesting thing to think about. Next, Flows programs seem to like to use Linux-specific features, even if it hurts portability. When the most systems are the same in some way, it's very tempting to abandon portability and use platform-specific features. Back in the day, it used to be said, all the world's of Axe. Then, all the world's in x86. Now, it's all the world's a Linux box. Clearly, if you're not on Linux, you hate this. But what if you are on Linux? Well, let's put it this way. I looked it up, and Kernighan and Pike's The Unix Programming Environment book is 357 pages. The more recent Linux Programming Interface book is 1,552 pages. Maybe it's an unfair comparison, but there's 1,200 pages of extra goodies if you can live with marginalizing a tiny fraction of your potential user base. So that's mighty tempting. One more question in this area. What about Wayland? The Wayland project to replace X11 is based on Linux-specific functionality. If it's successful, where does that leave the other Unixes? Next, Flows notes that modern Unix prefers tightly integrated components over generic solutions. This is another criticism of PolicyKit, ConsoleKit, UDev, and UDisks2. While it is true that these components have pretty set ways of interacting with each other, they do provide command line tools to interact with them as well. Also, is it fair to criticize them for this? Because while there are many loosely coupled tools on Unix, by no means all of them are loosely coupled. So just because these programs aren't loosely coupled doesn't automatically make them anti-Unix, I would say. Let's continue. So, not mentioned specifically in Mr. Eberhardt's flows definition, but mentioned at length in the blog post itself, was that Linux developers feel relatively free to deviate from standards as long as they feel justified by giving good reasons. For example, UDisks2 mounts removable devices somewhere else than where the Linux file system hierarchy standard, the FHS, dictates. And also, Fedora recently moved everything under /user and maintains FHS compatibility with just symlinks. So how old and non-optimal should standards be before we feel free to ignore them? So to summarize, the critics of Linux's direction are mostly right in their observations. Linux is sacrificing portability. Linux is moving away from shell scripting, at least for implementing core services. Linux is pushing forward pretty fast and leaving some things behind. But even though this may be true, I believe we should characterize these changes not as giving up on Unix principles, but an evolution. To explain why, let me introduce some new terms, courtesy of Larry Wall, author of Perl. Manipulexity versus whipupitude. The two foundational programming languages of Unix are C and Shell. C is good for complex things that need to be fast, but C takes a long time to write and debug. It has high manipulexity. On the other hand, shell programming is good for dreary one-off things that you as a user need to get done, maybe calling a series of other programs over and over. Or if it's not rocket science, but it's something repetitive to do on the command line, like renaming files or something, shell scripts are perfect. They have high whipupitude. Larry Wall mentioned it, of course, because Perl was supposed to give you high marks in both, or at least it tried. Anyway, I would argue what Eberhard was noticing and calling flows could be explained by two trends that certainly show Linux is evolving from its Linux roots, but it is not abandoning them. First is the manipulexity thing. This explains many of the changes that we've seen on the Linux platform. Re-implementing something like init in C instead of shell was an acknowledgement that the problem was complex enough now to require C. Shell no longer cuts it, which is fine. It wasn't meant to do everything. This isn't necessarily anti-Unix. System 5 init scripts are theoretically editable, but practically are never edited. You never edit them. They aren't whipped up anymore by the user. They're honestly part of the OS's core now. Now, Linux developers are users too and still love shell scripting, but it's not right for everything. And the Unix philosophy is not blind to that and takes that into account, I believe. The other thing to note is that all the world is a Linux box. It's kind of true and very tempting to assume that it's completely true. The Linux community has gotten so big that porting between Linux distros and Linux versions is a real issue, much less other Unixes. It's fair to demand Linux stay compatible to existing Unix standards, but for new things, they're being defined in Linux standards, like the LSB, that extend the Unix standards. We need to keep moving forward. Linux conformed to Unix during its early days, but caught up, and new feature development is naturally Linux-focused. I say it's now really up to the other Unixes to either expend the effort to forge their own paths, to define new cross-Unix standards, or face the fact and start adopting Linux-originated APIs. Even if we're okay with unifying on Linux as the open source kernel standard bearer moving forward, which not everybody is, of course, we still want to keep true to the Unix hacker ethic and carefully walk the line between raising the bar on standard features that all Unix users and Linux users can expect and keeping things loose enough so hackers can experiment and think outside the box. And I would argue that Linux is pretty good at this. Why has to do with how one builds a Linux distribution. So here's a rough diagram of how a Linux distro comes together. With Linux, you don't necessarily have to fork the kernel or any of the other parts. You control the combining of them into the new distro. The new distro bears the cost of maintaining its new combining recipe, but most of the ingredients are not forked, and work in upstream projects is still applicable to all distros. This is actually different from how other Unixes worked. In this way, the BSDs and the Open Solarises are more monolithic than Linux. So this is a place where the Unix virtue of combining small parts still holds, but at a different level. The benefit being that more overall OS modularity leads to more variety. This happens to let people who want to try something different just have to maintain the part that they changed and still keep up to date with the rest relatively easily. Let's look at this list of how Linux distros vary. Of course, now all distros are going to let you choose between text editors or between different web servers or things like that. So what this list is about is trying to capture the sources capture the choices that a distro has to commit to. That they can only choose one of the things and they can't choose all the things that can be realistically supported in the distro. So for example, number 4, you can only really choose to be a binary distribution, or you can be a source-based distribution. Or number 5, you need to choose as a distribution, are you going to have a long, a short, or a rolling support window? You can't pick all of those. You have to pick one, or you can have another distro that has another choice for that, but that's a separate distro. The amazing thing to me, looking at this list, is that there are so many distros to choose from and such variety that anyone can really insist on 5 or even 6 of these matching their preferences, and there's a distro out there that does it that way. You can even get a Linux distro that doesn't use the Linux kernel. So for me, this is a great reassurance that for every slightly controversial decision that a single distribution makes, there's an option out there, another distribution that goes the other way. Users are the ones, and they voice a preference on how they want their Linux platform to look by choosing a distribution, and possibly even contributing to that distribution's development. More contributors mean popular distros can improve faster and gain mindshare that results in features they choose becoming a universally accepted part of the Linux platform. This is exactly like the early Linux, like early Unix and early Linux. So we have ls and cat and awk and ping and chown because those programs got written and then people liked them and they stuck around. This process works the same today at the distro level. A single distro can make a decision for itself, and it may be wrong, in which case it loses users and relevance. It's the competition for users between distros that ensures the evolution of the overall Linux OS stays true to the direction that its users prefer overall. This is the Linux way. And that's it. So I guess now let's see if you all have any questions.
Great. Thank you so much, Andy. That was an outstanding webcast for us. We do have a few questions that have come in, so we'll let folks know. Folks, we're going to take as many questions as we have time for, and today's event is a preview of what Andy is going to talk about live at OSCON, July 22nd through the 26th. So we pushed out a URL to you all. If you're in the Portland area, we still have some tickets left. We'd love for you to come down, see Andy's talk live. He's going to talk more in depth, and you can maybe even meet him and shake his hand. So, Andy, if you're able to see some of those questions, we'll turn it back to you.
Okay. Just have one question here from Ricardo España, who asks, is there any manifest of Linux hacker ethics? Which is a good question. Well, I'm really using hacker here in terms of development and working on things that you like in a kind of unambiguous, ethically unambiguous way. So you're not the hacker is working on something that they like and developing software and building on software in that sense of the hacker word, as opposed to someone who's breaking into other people's machines or anything like that. So I don't know if I mean, certainly there should be some kind of manifesto for, if you're, ethics around breaking into other people's machines or not. But in terms of being a Unix hacker or being a Linux hacker, I think the ethics of that are pretty much like the just kind of the open source ethics, is that, or the making your code available to other people, improving what is interesting to you, and then giving back to the rest of the community so that other people can build on it. So I think that's what I'd say. There was a couple other questions, but they're a little bit technical, so I'm not sure if we wanted to talk about that or not.
Okay. Well, we'll let you take the questions that you deem appropriate for our event today. We did just get one in from Stephen. I'm not sure if you're able to see that. Are you?
Oh yeah. Okay. Yeah. Why don't we end on that question?
Perfect.
So the next question is from Stephen, who asks, can you comment on whether or which mobile OSs out now exemplify your concept of the Unix way? Well, that's really tough because so thinking of the Unix way in terms of openness, in terms of hackability, but also in terms of kind of a loose connection and being able to glue things together at the command line, that isn't really something that is enabled on mobile devices. I mean, you can. It seems rather specific to you're at a terminal and you're typing into the terminal, which is not something that you do on a mobile device. So in terms of openness, I mean, certainly you can look at at the different mobile OSs, either based on Linux or not based on Linux, and you can kind of grade them on how easy it is to how free is in freedom the software is on them. But in terms of Unix and the kind of tradition of Unix, I'm having trouble. I would have trouble to say that you can separate the whether you can really say that you can have a Unix platform unless you have a command line. Honestly, unless you have those tools, then I would say that it's hard to exemplify the Unix way. So let's why don't we end it there?
Great, Andy. Thank you so much again for presenting a really outstanding webcast for us all and for sharing your knowledge and expertise with everyone today.
Happy to.
Great. And folks, again, we'd just like to remind you all that we do have the O'Reilly OSCON conference. It is our flagship conference, all dealing with fantastic open source topics and emerging topics and technologies. And Andy is one of our speakers there. He's going to talk about Linux, of course, and give you lots of good information and do a lot of live things there. So we pushed out a URL for you all. You can read more about his talk at the conference, and we do still have some tickets left. So those of you in the Portland area, we hope you can take advantage of that and attend the event. And again, meet Andy, shake his hand, and I'm sure you're going to have just a really great time because lots of good things going on there. As we close out the program, we would like to thank our sponsor today, Media Temple, and we would like to let you all know that Media Temple, from its inception in 1998, has been on a mission to help people and businesses succeed online. Over 125,000 customers in 100 countries now rely on Media Temple's simple tools for domain registration, web hosting, business applications, virtual servers, and other cloud services to provide more than 1.5 million websites. Media Temple takes pride in offering a premium service at a competitive price along with exemplary 24/7 customer support. Media Temple's customers range from everyday people to top bloggers, creative professionals, and small businesses, as well as large enterprises like Starbucks, Adidas, Samsung, and Toyota. With 200 dedicated U.S.-based employees, Media Temple has been repeatedly recognized as one of the fastest-growing companies in North America and one of the best places to work. You can find more about Media Temple, find out more anytime on their website, MediaTemple.com, or on Twitter @MediaTemple. Again, folks, thank you, Andy. Thank you, everyone, for attending. This will conclude today's webcast. Goodbye, everyone.